Thanks very much. I hope you still clap again at the end. My name's Jez Humble. I work for Chef. We make configuration management software that makes things awesome. I co-authored these two books, and I'm here to talk about maintainable acceptance test automation, which is difficult and interesting. And I've never had such a big audience to hear about test automation, so that's quite exciting. It's the prestigious after lunch slot, so I'll try and keep it exciting so that you don't fall asleep. But fortunately, I can't really see anyone, so I won't know. So the basic philosophy that I have about testing is best expressed by a guy called W. Edwards Deming, who was one of the founders of the Lean movement. He's an American statistician who helped build the total quality movement in Japan that led to Japanese manufacturing becoming the best quality in the world after the Second World War. And he has this to say about quality, which is a quote about manufacturing, but it also applies to software development. He says, cease dependence on mass inspection to achieve quality. Improve the process and build quality into the product in the first place. We cannot take a software product or any product that has not been developed with quality built in and try and test in quality or scalability or availability or usability or any of these qualities. That can't be a separate phase that happens afterwards. You have to actually engineer that into the product, which means it's the responsibility of developers to do that. And this is a theme you'll see throughout the talk. And there's two important implications for software development from this quote. One is that testing should not be a separate phase after development. Testing should be part of the development process. The cheapest way to fix a bug is to not check it into version control in the first place. That's why we have automated tests that we can run on developer workstations before we check any code into version control. The second important, thing to derive from this is that quality is not the responsibility of testers. Quality is the responsibility of everyone on the team, because quality is a business decision. Quality is not something objective about your system. Quality is subjective, and it's something that's experienced by the user of your system. So the only way that you can really know quality or come to quality decisions is by using the software and by making business trade-offs. It may be the right thing for your users to get a particular feature very quickly to your users and accept that there may be some quality trade-offs because that's what they want. Or it may be the right thing to get some features to users more slowly, but have higher quality in terms of defects. That may be the right thing to do as well. I mean, Microsoft built a number of products which came to market very, very quickly and were very, very successful, even though they weren't 100% defect free, and it was very successful for them and for their users. But if you're building, for example, not that Microsoft is particularly any worse than anywhere else, but if you're building, medical hardware or space hardware, you probably have a different set of trade-offs that you want to make. So quality is not something that resides in the tester to make decisions. It's everyone's responsibility. So in this talk, I'm going to talk about how to create high quality acceptance tests and how to structure them. I'm going to talk about teamwork, and I'm going to spend a little bit of time at the end about test data, because test data is problematic and people often get it wrong. So this diagram is from a guy called Brian Marek, who was one of the Agile Manifesto signatories. And he talks about the different kinds of tests that we can use in our systems. And they are divided into different types. Tests that support programming on the left versus tests that critique the project. And at the bottom to the top, technology versus business-facing tests. So on the bottom left here, we have things like unit tests and component tests. And these are tests that developers write to validate that the system, the APIs they're building, behave according to their expectations. In my experience, the only way to build maintainable suites of unit tests is by doing test-driven development, which means writing the tests first before you write the code that makes the test pass. And the reason I say that is because unit testing is test-driven development is not actually about creating suites of unit tests. Test-driven development is about making sure that your API is testable. And as a side effect of doing that, you get a nice suite of unit tests. But the suite of unit tests isn't the main benefit. It's having an API that's testable. And so unless you write the tests first, you end up with a system that's not easy to test and an API that's not easy to test, and trying to retrofit unit tests into that kind of system, even if it's just after you wrote the code, is much, much harder, and those tests become expensive and painful to maintain. So who in this room writes tests first? Engineers write tests first. I think that's probably the largest proportion I've ever seen. That's something like 30%. So that's great. Very happy to see that. On the top right is the things that we cannot automate. So showcases, usability testing, exploratory testing, that has to be done by people. And this is what our testers should be spending most of their time doing, because that's what people are really good at. On the top left is what I call functional acceptance testing. These are tests that validate that the system delivers the expected business value to users. And they're typically end-to-end tests that run in a production environment with reasonably realistic load and data sets in some cases, but they're system-level tests. These are going to be the focus of today's session because they're hard to write in a maintainable way. And this stuff forms the basis of your regression suite. And the crucial thing is that all this stuff should be automated. Neil Ford has a joke that when human beings do the things that computers could do instead, all the computers get together late at night and laugh at us. And nowhere is that more true than if you have human beings doing these things manually. That's a tremendous waste of human talent and intelligence. It's 2014. The patterns and practices and tools exist to automate this stuff, and it should not be done manually. Humans are also very bad in general at performing repetitive tasks. We get bored. We start thinking about what we're going to watch on TV or what we're going to have for lunch, and then it's not necessarily a great way to make sure that the system behaves exactly as expected. Which is not to say we shouldn't do it at all. A key part of exploratory testing is manually going through the application, but the output of exploratory testing, or one of the outputs, is helping to improve the automated test suites that we run. So there's absolutely checks and balances. If we do a good job of writing our functional acceptance tests, we can use that to create the basis of performance tests. And then these tests are very important to test scalability, security, all these kinds of things. The crucial thing about them is, they can't all be automated. Some of them still have to be manual, but you should be doing these all the way through your project right from the beginning, because these tests are testing the architecture of your system. Martin Fowler defines architecture as the stuff that's hard to change. And so if you test the stuff that's hard to change at the end, you will find out that it's not going to produce the expected results. Almost invariably, unless you're writing a trivial system, you'll find it doesn't scale in the way you expect, that it doesn't fail in the way you expect, that there's security problems. And if you discover that at the end, it's going to be really hard to change it. So we should be running these tests and validating these architectural characteristics of our systems right from the beginning as soon as possible, so that we can change the architecture to meet our needs from early on. So I'm going to ignore this stuff for the rest of this session and briefly talk about this stuff. Many of you will have seen Mike Cohen's diagram, and really, you don't want to get too hung up on the different proportions. The important thing is that there's more unit tests than there are service tests, and more service tests than there are UI tests. And really what this is about is saying, we have a large number of localized technology-facing unit tests and a smaller number of end-to-end business-facing tests. And crucially, when one of these breaks, one of your acceptance tests breaks, what that's telling you in many cases is that you're missing unit tests. And one of the feedback mechanisms is you should then create a unit test to validate, to catch the same bug more cheaply in future. So moving on to the principles of acceptance testing. Principle 0, because we're 0 indexed, is that it's hard to write good acceptance tests. What do we mean by good? Well, a good acceptance test means when the tests are green, you have some high level of confidence that the software is actually working and releasable. And conversely, when the tests are red, we have some level of confidence that there's actually a bug, rather than, just the tests are flaky, or, there's some problem with the environment or whatever. So good tests give us confidence that our software is releasable. Bad tests are basically tests that we ignore or that we don't trust. Just to give you an example of some size, I used to work at ThoughtWorks, which had a product called Mingle. In the 6 years that evolved, we went from 20 tests in 2006, 500 lines of code that ran in 2 minutes. And then 6 years later, there were 3,000 tests, 50,000 lines of code that took 12 hours to run. We ran them in parallel on a big grid and got feedback within 55 minutes. Those run 7 to 10 times a day for many years across many offices. It's probably even bigger now. But this is very typical in terms of the expansion of the system. And what it shows us is that your tests can become pretty complex and sophisticated and painful to maintain, frankly. So why do test suites decay? I mean, everyone who's done serious automated testing will know that test suites do decay over time. And part of the problem is the same reason that code does. We don't pay attention to refactoring it, to making sure that we apply good architecture and good design principles like encapsulation and so forth. Someone once said, I think it might have been Brian Kerningham, that if you write the smartest code you can, by definition, you're not smart enough to debug it. And a similar thing is true of tests. If you write the smartest tests you can, it's going to be actually very painful and hard to maintain it. Often test code is more complex and sophisticated than the production code that it's testing. And so this is super important to bear in mind. If you don't treat it with the same respect as you treat your production code, what you'll find is that it becomes unmaintainable very, very quickly. The other problem is paying attention to expressing intent, making sure that the tests actually are very clear. And who went to the talk on JavaScript testing this morning? Yeah, so a few of you. But that was a point that was made very, very clearly and well this morning, is that your tests have to be readable and express very clearly what the test is trying to do. Otherwise, it's very hard to actually maintain them over time. And then the third problem is when only the testers care about maintaining the tests. That leads to some very severe problems, which I'll talk about later. But mainly, the biggest problem is that in order to create maintainable tests, you have to have a testable architecture. And if there's no feedback loop, that can't happen. So, principle 1, tests the first-class citizens of your project. We talked about this. You have to keep it as well factored and encapsulated as your real code. So, how do we prevent decay? Treat it like production code, refactor it a lot. Don't repeat yourself in the way that you expressed your test mechanics. Make sure that your test mechanics is nicely encapsulated, so you're not repeating yourself all the time, and so that your tests express very clearly their intent. Don't repeat yourself. Make sure that your test intentions are very clear as well. And then finally, who uses record and playback tools to build their test suites? Are you using record and playback? Okay, good, or you're too embarrassed to admit it. Either of those is fine. We don't use drag and drop tools to create our software anymore, and the same is true of tests. We shouldn't be using GUI-based tools to generate test suites either. So, the solution, and I'm not as keen on this slide as I used to be. I used to be very clear about this, that we should use natural language like as in Cucumber tests to express intent, and then a general purpose language to express test mechanics, and then a tool that lets you operate in either domain. Obviously, Cucumber is probably the best known example of that, although there's a number of other tools that let you do that as well. The reason I'm not as keen on this anymore is that I think there's an overhead for that. You have an abstraction layer which has to translate between the intentions of the test and the mechanics. So one tool that I used to work on was called Twist, and there was this nice thing where basically you could express what the test was doing in natural language, and then you could press play and actually execute the tests. And behind the scenes, it was all Java. There was a Java API sitting behind that, where the names of the methods in Java were, what's written in the test scripts here, and it would keep everything in sync. So when you refactor the Java, it would update this and vice versa, and you could pull things out. And that's very nice, but it does create an overhead. And that overhead, I think, now is really only worth it if you have either testers or business users who are really uncomfortable with writing code. If you have small collocated teams where everyone is an engineer, you can probably just use JUnit. and that will be absolutely fine, and get rid of the overhead. But if you do have mixed teams where there's non-technical people who need to collaborate with the engineers to define the tests, then it is very useful to be able to do this, and there's lots of great tools that let you do this very powerfully. One thing that is, I think, still valid is this thing called the page object pattern. And this doesn't apply so much to single page applications, but certainly with multi-page applications, this is essential to be using. And what the page object allows us to do is basically decouple the implementation of our tests from the expression of the intentions of the test. So the way this works is every page on your application will have a class associated with it, like this one, and it will have a bunch of methods that you can call from your top-level test script. And in this class, all the interaction with the system under test is encapsulated. So anything to do with actually pressing buttons or reading stuff from the system under test is encapsulated in these classes so that your test scripts don't have to know about that. You decouple your test scripts from how the application actually how the UI is actually built. This is important for several reasons. Firstly, it makes the intent of your tests much clearer, makes the test scripts much more readable. And secondly, as you change the UI of your system, you don't need to then change all the test scripts. If I change part of the UI for the login page, there's only one place in my test suite that I need to change, which is this object, this class that understands how to interact with that page. The other really nice thing you can do with this is you can turn these classes into interfaces and then have multiple implementations. You can have an implementation which is to talk to the web UI, and then you can have a second implementation which talks to the service layer. And that means you can reuse the same test scripts and run them against either the web or the services, and you don't have to create different sets of scripts. Another thing that's possible is to have different implementations for, say, an iPhone driver or to drive Android. So again, you can use the same set of scripts at the top level, which express user journeys, which I'll talk about later, and then say, okay, we're going to run this suite against the iPhone client, and we're going to run the same suite against the Android client, and that's very powerful. It lets you reuse the same sets of scripts. So it's great in terms of good encapsulation, about making sure that when we change our system, we don't need to change big sets of our tests. And it's also great to be able to run different drivers against different layers of the application or different clients of the application. It's very, very powerful. So I'm going to switch a little bit and talk about how we do process for testing. We always should be starting with acceptance criteria. How do we know that the functionality we're building is done? What are the acceptance criteria for knowing that we're done with the functionality we're about to develop? And that's something that should be decided by the customers and the testers together. And this is important because the testers, part of the role of a tester is to make sure that they understand the user's point of view. And so by having the testers and the customers collaborate, this is a great way to make sure the testers really have a great view of the way the system should work, which is very important. And often the tester on the team is the best person to talk to about how people will really use the system in real life. That's why it's such an important role. And once we have the acceptance criteria completely written, and that should be done before any development work starts, during development, we'll implement the tests. Now, for unit tests, I am very religious about making sure you write your tests first. For acceptance tests, I'm not so religious because I've worked successfully both implementing the tests before writing the code and afterwards. And I don't think it makes so much of a difference. The crucial thing that's very, very important is that developers should not be able to say they are done with their work until they have working acceptance tests. Like, no engineer should be able to say, oh, I'm done, until they have the acceptance test working. So one of the case studies that I like to talk about is HP LaserJet firmware. There's a book on HP LaserJet firmware system, FeatureSmart, where they talk about writing a very sophisticated acceptance test harness for firmware. I normally carry a copy of the book with me, I don't have it today, just to spank people who say that automated acceptance testing is too hard, because they wrote thousands of acceptance tests that actually talk to the logic boards and get signals back to validate that the firmware actually works. I mean, it's very, very powerful. And they had a couple of rules. One of the rules was if you come to the director to showcase your functionality in order to get your story points, the director will ask you two questions. One is your code checked in on trunk? And if it's not, then you have to go away and do that. And the second thing is, are you going to showcase the functionality by running the acceptance tests? And if you aren't going to do that, again, sends you away. You can't showcase your functionality and certainly not sign your story off as dev complete until your acceptance tests are finished. That's very, very important. And this is something that developers and testers should work on together. And I actually physically mean together. I strongly believe that testers and developers should sit down and pair program on writing the test implementation. And the reason for that is it's very hard to write testable software if you're not getting feedback and actually being involved in writing the tests. Again, retrofitting automated tests onto a system that was not designed to be testable is very, very hard, and those test suites are very unmaintainable. And the only way for developers to learn how to write testable code is to be involved in the creation and evolution of the test suites. There's just no other way to do it. And that's one of the reasons why when you have the testers on a different team or, God forbid, in a different company or a different country, you end up with very painful, unmaintainable test suites that developers don't care about, that cost you a lot of money and provide very little value. It's because the developers never get the feedback on how to make the system testable, which is a precondition for writing maintainable acceptance test suites. So, quick pop quiz. Who has testers working on the same teams as developers? Okay, that's great. And, sorry, but, hands up if you have testers on a different team. Okay, a few people. Anyone outsource their testing to a different company or a different country? Yeah, and I'm sorry, but it just doesn't work. That's the reality. They'll always be playing catch up. You'll never get the value that you expect, and you try and mitigate that by outsourcing to a country with a low cost of labor. You end up with cheap, unmaintainable tests that don't give you value instead of expensive ones. So this is also important because what happens here, often a lot of testers are uncomfortable about writing test automation because it's not perhaps their special skill. And frankly, a lot of developers don't understand how to test. That's the reality. And so having developers and testers pair is a great way to share skills, for developers to understand more about testing and for testers to understand more about how to do automation and write code. And, I don't think anyone expects that, testers are going to become the best programmers in the world, or that, frankly, developers are ever going to become great at testing. But at least having them together, they come to appreciate and learn each other's skills. And that kind of fear of, I'm uncomfortable with automation because I don't know how to do it, that kind of goes away a lot when you have those people actually collaborating physically in person. So, what is the role of a tester or quality analyst? I think the first thing to say is a role, not a person. And you can have people play different roles on the team, and that's fine. There's people who say we don't need testers anymore, and I kind of think that's crap. I think you need people playing the testing role. You may not need someone who's a dedicated tester, but you need someone who's playing that role on your team, who has that experience and the skills and has learned the behaviors that are necessary to succeed at that, because it is very different from developing, and some of that will explain later. The second one is that testers are not failed developers. This, unfortunately, is a very common myth in our industry. And as I said earlier, writing good, maintainable acceptance test suites is as hard as writing production code. And the idea that someone who's a crappy developer is going to be effective at that is just absurd. So this is still a very pervasive myth in our industry today, and we really need to scrub this away. The main job of the tester is to advocate for the user and then make the quality of the system transparent so that we can make the right business decisions as a team. And again, not primarily working on manual regression testing. That's a sign that something is very badly wrong. Instead, what I generally see is that they're focused on exploratory testing and then helping to build and maintain and curate the suites of automated acceptance tests. and frankly, helping the developers understand what good testing looks like and how to test their code effectively. There's a coaching piece around it as well. So that's what I would expect to see on high-performance teams. So takeaways from this. You have to have passing acceptance tests to say you're done with anything. Encapsulation is super important. We should apply good architectural principles to our test suites. And then these acceptance tests are owned by everyone, and they're everyone's responsibility. So, principle 2, always interact with the system under test the same way that a user would. Acceptance tests, automated acceptance tests, are demonstrating that the system provides the expected business value, and that means talking to the system the same way a user would. So, for example, I think acceptance tests should generally be black box tests. You shouldn't be reaching into the application or using backdoors. What that means actually is that your API isn't very good. Good acceptance tests will exercise the API to do setup and create data, as we'll discuss later. And if you have to reach into the application, that's normally a sign that actually you have architectural problems. And this is an important feedback loop from writing maintainable test suites back to the architecture of the system, which again is why it's important for the developers and testers to be talking to each other. So, you see this often in browser-based tests, and it's actually very hard to create reliable browser-based tests. Anytime you have tests failing in CI, but you're running the app on your developer workstation and it's fine, that's a symptom that you've got, you're not interacting with the system the same way that a user would. And it generally indicates that the user interaction patterns differ from the way that the test mechanics are working, and you need to fix that. So, if a test script clicks a link to reveal a drop-down and it happens straight away on your machine, don't assume you can proceed. Wait for the drop-down to trigger the events on the UI that will cause other things to happen before you proceed. If there's Ajax-like behavior, if you have things with Ajax, you should wait for those calls, which almost all of us do these days. You need to explicitly wait for those things to come back and render changes on the page before your test proceeds. Any kind of JavaScript-heavy things which need non-zero processing time, you're going to have this problem. So, who has put sleep statements into their tests? Okay, yeah, we've all been guilty of this, right? And then what happens is that some clever person comes along and takes the sleep interval and creates a constant because, we're factoring out. It's nice. And then, the test fails, so you increase the constant and then increase the constant. And before you know it, like 99% of your test runtime is just wait. So turns out that's not a good idea. And again, interact with the system the way a user would. I don't click on a thing on the page and then go, la, 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 for like 10 seconds and then open my eyes and see what's rendered on the page, right? What I do is I look, I might look away and then look back and actually check to see if the thing's rendered. So what you want to do, very standard pattern, have a loop that goes around every 100 milliseconds or whatever, and then times out after 10 seconds, and just use that all the way through. An ex-colleague of mine wrote this very simple Java thing on GitHub, which implements that for you that you can reuse. If you want to get smart, if your JavaScript framework provides hooks, you can actually loop into the event hooks in order to have event-based browser testing, and lots of modern JavaScript frameworks will help you out with that. So remember, go back and refactor your tests. That's very important. Use layers and encapsulation. And then use the page object. That's very important. So principle 3 is curating the structure of your test suites. So a lot of people use their acceptance criteria as the basis of their acceptance test suites and just kind of automate the acceptance criteria. So who's familiar with this format, as a I want so that yay. So we have this story format, and then we have the given when then format. So given states the initial state of the system as we expect it when the test starts. When is the actions that we perform on the system, and then is the expected state at the end of the test. So it's kind of state precondition, actions, expected state at the end. And so this has become pretty common in agile circles as a way of expressing acceptance tests. And then what happens is, 100 stories later, you've got a ton of these things. And what typically happens is the system evolves, is that these tests here are no longer really valid. And, they'll fail, and you'll go back and look at them, and you'll be like, would somebody actually be doing this in real life? Not sure, don't want to delete the test, that's a bit scary, I'll just kind of make it pass. And then your tests really degrade quite rapidly as a result of doing that. What we want to move to instead is what's either called scenario tests or journey tests, where each acceptance test expresses a valid user journey or path through the system. So you might have, if you're building a shopping site, a scenario which is to buy a product, where you go through from, your first interaction with the site all the way through to, making sure the email is sent when you've bought your product. And then we might have a new story which is about a gift wrap option. Are we going to write a completely new acceptance test for the gift wrap option? I would argue not. I would say what you're going to do is take your existing journey test and then add, gift wrapping option and validate that the gift wrapping option was mentioned in the email rather than adding an existing test. And so, we start with features and then we turn features perhaps into stories depending on how your process works. But we shouldn't just be blindly automating acceptance criteria. What we should be doing instead is identifying user journeys. So a journey, a journey is the path that a persona takes through the application. Most applications don't have very many personas. And so thinking about what those personas are and the journeys they go through to use the system, and not just end users, but also administrators and other people who have to use your system, you have to take them into account as well. We see Amazon, but I'm sure there's a bunch of scenarios for people who have to administer Amazon, and the people sitting in the service centers, they're super important as well. We have to consider their user journeys through the system as well, if we're going to deliver a good customer experience. At the beginning of the development of your system, you're going to be creating lots of new user journeys. But for systems that are, evolving or mature, you're not going to be adding lots of new user journeys in general. You're mainly going to be making modifications to existing journeys. And knowing how to do that and what the trade-offs are one of these kind of very important analytical skills that testers know how to do. It's an art, it's not a science. And there's a whole bunch of trade-offs in working out what the journey should be and what cases you're going to cover, and these are the things that testers understand how to do really well, and frankly, developers generally aren't so good at. And so, you might have a journey test for a user buying a book. You log in as Bob, you search for something which is non-trivial, you're going to test some of the search functionality here and make sure that that's right. You're going to get a certain number of pages of results, make sure that, at least this book is in the results, add 2 copies of the book to the shopping cart, gift wrap one of them, and proceed to checkout. And so you can see here, this test is actually testing a bunch of different bits of functionality in a relatively sophisticated way to make sure that, we've the high value functionality is working in a kind of concise and efficient way. So creating journey tests like this is an art, and it's something that you can be very sophisticated about. And there's whole branches of testing theory dedicated to how you do this in an effective way. But the key is, we shouldn't just be blindly automating all our acceptance tests. We should be thinking about the trade-offs. How can we create an acceptance test suite that's not enormous, but that covers the high value functionality and that's also maintainable over time. So when you have a bunch of acceptance tests that are based on story tests, we need to think about extracting journeys from them, from making them fast and making them fast to run, and making sure they can run on developer workstations. That's critical. Test the most likely paths and the high value paths, but not every possible path through the system. Every application has an almost infinite state space. It's impossible to cover the entire state space with acceptance tests. That's why, test coverage, who's got a test coverage metric that they monitor? It's a lie. You can work out the number of lines of code you're covering, but that gives you no indication on the size of the state space that you're trying to cover with your application. And so, the idea that 100% test coverage is actually going to make sure there's no bugs in our application is a myth. And we need to be real about this and accept that we're not going to be able to test the entire state space, and again, make that trade-off between having enough tests that we have high levels of confidence that the system's releasable, but not having something that's completely unmaintainable. And that may vary depending on even the life cycle of the application. That may change over its life cycle. So it's something we constantly need to be thinking about. And then typically what you'll have is a set of negative tests and edge cases that you use to create a regression suite, which is independent from your main acceptance suite. Your main acceptance suite is, when this passes, I'm confident that the thing's releasable, and then I'll run a regression suite which does sad path and alternative paths and edge cases just to give me some additional confidence. And this can be created as a feedback loop from defects in production. When you have a defect in production, there's a feedback loop from any incident in production to how can we reproduce this bug as quickly as possible and efficiently as possible with as little data as possible. And that may not go back into the main acceptance suite, but it might go back into a regression suite to make sure that that defect doesn't happen. There's always a feedback loop from broken acceptance test to new unit test, from defect in production to new acceptance test or new regression test, or to exploratory testing indeed. And those feedback loops have to be managed and cared for and maintained, which again is one of the primary duties of testers. So, principle 4, everyone owns acceptance tests. It's not just for developers, it's for everyone. When an acceptance test breaks, there's at least 4 reasons why that could be the case. You could have an environment which is a bit flaky, that's not well configured. You could have a bug in your test. Maybe one of the assumptions behind your system has changed. That thing where the first set of tests that ran, assumed that the system was one particular way. As the system evolves, those assumptions change and the tests are no longer valid. Or maybe, if you're really lucky, your test caught a bug. Hooray! So first of all, we have to fix the problem, but then we have to make sure that problem doesn't happen again. So if you have an acceptance test failure, add a unit test. If you have an environmental problem, you should maybe spend some extra effort on configuration management and making sure that your environments are properly maintained and they can be created purely from information in version control. And we want to be able to detect failures fast, which means that we want good coverage in our unit test suite, but we ought to optimize our process for time to fix tests. So one of the metrics for continuous integration that people often monitor is how often the CI build fails. I don't think it's very important to know how often the CI build fails. What I think is important is how long does it take for the CI build to be fixed? What's the time to fix? And we need to make sure our process is optimized for time to fix. Because what happens when you go to organizations with broken testing processes is you see the tests are just broken all the time because no one cares about them. So in the JavaScript talk, the guy mentioned intermittent failures. Intermittent failures are not just, flaky tests are not just useless, they're worse than useless because they cause people to lose trust in the test suite. And that's very, very bad. So what we should do with intermittent tests is move them into a quarantine suite. So you have a separate suite of tests and you can just mark them up as being flaky, and then they don't run in the main acceptance test run. They'll run in a separate test run just for those flaky tests. However, you want to monitor the proportions of the tests so you don't end up with 90% of your tests in the flaky test suite. That's a sign that something is very wrong. And the important thing is, you should go through the quarantine suite regularly, and you should not be afraid to delete. For some reason, people have a real mental block about deleting tests. But I would much rather have 5 tests that I can really rely on, that when they're broken, I'm confident there's a bug, and when they pass, I'm confident the system runs, than I would to have 5,000 tests that are flaky and no one cares about and are always broken. So just delete the ones that you're not sure about. As long as there's other tests that do give you confidence as well. That's why we have version control, so we can delete things with confidence, and so we don't have to maintain those lines of code that we're not sure are adding value. Always go through and make sure that your lines of code for your tests are adding value. And there's a good article by Martin Fowler on non-determinism. Non-determinism can be caused by many different things, and it can actually be quite useful. Sometimes it'll tell you about memory leaks or thread locks and things like this that you couldn't catch in any other way. So flakiness, when you see flakiness, you should actually investigate it and be like, oh, maybe this is demonstrating some unusual edge case rather than, oh, the tests are flaky again. I don't care. Let's run them again. Oh, they passed this time. Everything's fine. A key problem a lot of people have is how to deal with external systems. So if your system is talking to a bunch of external systems, how do we manage that? And the first thing to say is that if you actually need an integrated environment in order to do your testing, you have an architectural problem. You should be able to run your acceptance test suite on a developer workstation for an application without having to have all the applications or services it depends upon be live. And if you can't, that's an architectural problem with your system. If you have to get an integrated test environment, which you may, who has to wait like more than a week to get an integrated test environment for their application? Come on, I don't believe you. Really? Okay, there's a few hands up at the back. Okay, you must be working in very excellent organizations, because that's very typical in the systems I see. Make sure you architect so that developers can run tests on their workstations without having to talk to external systems. Not all tests should call external systems. We can parameterize connections to external systems so that we can talk to, dummies, mock systems or staging systems rather than the main systems. And then what you can do is you can run your integration smoke test before the full acceptance suite to make sure, for example, that you can talk to the database, that you can talk to the message bus, that you can talk to order processing systems and so forth before you run your main acceptance, before you run your full suite, because there is nothing worse than running an hour worth of acceptance tests and then finding they all failed because it couldn't talk to the database. There's a pattern that I've seen come in pretty useful called the impersonator pattern, where what you do is you create a proxy against the remote system, and you run the acceptance test once against the real remote system, and you basically sniff everything off the wire and store it in a database. And then when you run your acceptance tests again in future, it doesn't talk to the remote service at all. Instead, it just pulls stuff back from the database. So if you have a problem where you have to talk to an expensive service that is very difficult to get a real copy of, this is a pattern that we've seen work really well in real life to help manage that. So this is basically a countermeasure if you have this problem with integrated environments that makes it very hard to test them. And there's a piece of open source software called Mountebank that does this for you. So the final principle I want to talk about is managing test data. And this is a very thorny problem in acceptance testing. So first of all, I want to state there's three different types of test data that we need to consider. The first kind is test-specific data. So this is the data whose state we actually care about when we're doing our assertions at the end. So if you have a test to buy something, you're going to care about your account balance at the end. You're going to assert that the correct amount was deducted from your balance, so that's test-specific data. You will then have test reference data, which you need to set up, but whose state you don't care about. So we might have to set up a person with an address and date of birth and whatever, and we may not actually care about their address at the end of the test. So that's test reference data. And then finally, there's application reference data, which you need to set up for the application to run, but you don't care about its state at the end. So this is things like country codes or product types and stuff like that. So the key thing is, we don't want to be managing test-specific data and test reference data using database dumps. That's a common pattern. In my experience, it leads to very bad outcomes for a few reasons. Firstly, we need to make sure our tests are independent. Who has tests where you need to run the tests in a specific order, one after the other? Okay, that is really problematic for two reasons. Firstly, what always happens is that you change, you've got to run your test A, then B, then C, then D. I make a change to test A because the system has changed or I'm adding some new stuff. Test D suddenly starts failing, because test D is expecting something in test A to be set up a certain way, and we change it, and now test D is expecting something that's not there anymore. And so that's a cause of flaky tests, and it also means we can't run our tests in parallel. And it's very important to be able to run your tests in parallel. Firstly is the basis of actually being able to make sure you can run them in a reasonable length of time, but also because we can then use our acceptance test as the basis of a performance testing suite using a technique I'll talk about in a minute. So we need to make sure tests run independently of each other. And the problem is when you're using database dumps and these kinds of other techniques, it becomes very expensive to do that. So don't use production data dumps for acceptance tests. They do have uses. So for performance testing or for staging, production database dumps that have been cleansed properly to remove identifying information, based on whatever regulations you have to care about, those can be very, very valuable, but we should not be using them for our acceptance test suites. What we should be doing is setting up the minimal amount of data that we can in order to actually run the test. It's just the same as when you find a defect. You want to find the minimum amount of stuff you have to do to be able to reproduce the defect. You need to take that mentality to use for your unit tests, for your acceptance test suites as well. What you can actually do to ensure that tests are independent, I talked about the page object pattern earlier. Where is it? Yeah, what you can do is actually have UUIDs inserted automatically by your page objects so that every object that's created in the system has an independent UUID. So, I'm going to call this with user Jez, and the login page is going to keep a UUID that it remembers for all other interactions with the system that makes sure that that object's unique. And then the tests cannot stomp on each other. It's impossible. And then what you can do, which is really nice, is you can say, okay, I'm going to run 50 versions of this journey and 1,000 versions of this journey and 10,000 versions of this journey in parallel, and use that as a performance testing suite. And you can actually look at your production logs and see what kind of journeys people make through the system, and then create and then run sets of acceptance tests in parallel to simulate real user load on the system, which is a really nice trick, but you can only do it if you can run multiple instances of your test at the same time against a single system under test. So I'm just going to wrap up a couple of things. This is the recap of what we covered, making sure that we treat our acceptance tests with the same love and care and attention as our production code, that we interact with the system under test the same way as a user would, and that we manage that diff very carefully as part of our architectural constraints, that we curate our user journeys and just don't blindly automate our acceptance tests, that we're all responsible for creating and maintaining our acceptance tests, and that the acceptance tests should always own their own data and set up their own data. And finally, the takeaways: everyone's responsible for quality. I can't emphasize that enough. And high quality test suites are always being curated by the whole team working together. We're always working to make sure that those test suites express real user journeys through the system. And finally, the exhaustive story level testing, you shouldn't just take that and turn that into your acceptance test suite. So I think we have maybe a couple of minutes for questions. So what questions do you have? Yes, there's going to be a microphone.
Thank you. So do you have any getting started tips for teams or developers who are unfamiliar or uncomfortable with testing? Just kind of how do you promote that culture and that mentality?
So I think what you have to do is start small. I've seen teams where they're like, okay, we're going to implement test automation. Now we're going to stop and implement loads of unit tests and automated tests. And I think that's a really bad idea. Any kind of big bang process rollout is always pretty disastrous. I think it's the same principles for any cultural or process change. Find people who are enthusiastic about it. Find people who want to do it and give them the time and the resources and the support to experiment. You're going to find that what works for other teams is not going to work for you because your context will be different. So give people time and resources and training to experiment with different things and just try adding things. So you might have, a pair of people who just, they're going to make it their rule from now on that they're going to write an acceptance test for every piece of functionality they develop, and get them to try that and let them experiment with it. And then as you find stuff that works, then get other people who want to experiment with that, talk to them and slowly and organically roll it out. But any kind of thing like this is going to be experimental. You're going to mess up the first few times. You're going to learn a bunch of stuff in the course of doing it, and you have to make sure that it's safe for people to experiment and learn and find what works and then organically roll it out, which takes longer, but it's much, much, much more likely to succeed and make sure that that culture takes root. Does that answer your question? Yeah.
Yes, hello. Could you please elaborate a little bit more on how would you map the journeys, user journeys to the tests or to scenarios?
So how do you map the user journeys to the scenarios? I think, when you're first starting an application, when you're completely greenfield, it's a reasonable thing to do to take your acceptance criteria from your story tests and use that as the basis for your acceptance suite. And then what will happen is, as your system evolves, over time, you'll start extracting out journeys. You'll see, oh, well, this acceptance test and this one, that, I've got these acceptance criteria, and they're kind of testing the same thing as this. Can we fit them into this user journey? And so start with just standard story-based acceptance tests, and then as the system evolves, you're going to extract out user journeys. And again, you're not going to get it right the first time, and as your system evolves, you're going to have to keep revisiting it and pulling out different things, but always return to who are the personas? What are the main journeys through the system for those personas? Start with analysis and thinking about who are the people who use the system, what are the main things they do day to day, and this is where your UX people come in really handy, because they're the people who will hopefully know about how your users interact with their system. Work with the UX people to see how people actually really interact with your system in real life, and make sure that journeys reflect the reality of how users interact with your system. And then there's a feedback loop there. As you observe people, you might be like, oh my God, it's really horrible to do this. And that should feed back into development. How do we make the application more usable? Yeah.
Great. That's actually everything we have time for. I guess we could have been doing a Q&A for another hour or so. But give a great hand to Jez Humble.
Thank you.